Hello everyone, I am Dr. Buddhika Aliyanige. So today I would like to talk about empirical formula with examples. Let's talk about the question 1. A mineral contains 48.41% copper, 19.02% arsenic and 32.57% sulfur by mass. So what is the empirical formula of this mineral? First let's determine the molar ratio. So each percentage value, let's divide by atomic masses. So 48.41 divided by copper atomic mass 63.546. Then the answer is 0.762 moles. For the arsenic, 19.02 divided by arsenic atomic mass 74.92. Then moles 0.254. And sulfur 32.57 divided by sulfur atomic mass 32.065. Answer is 1.02 moles. Now you can see we have decimal values, decimal numbers for the number of moles. So we cannot get the whole number ratio for the empirical formula. So let's divide these three numbers by the smallest value to get the whole number ratio. So among these three numbers, the smallest value is 0.254. Then all three numbers, let's divide by 0.254. Then the whole number ratio is 314. Our empirical formula or empirical formula meaning is the formula that contains smallest number whole number ratio of each atom is Cu3AsS4. Let's talk about next question. So what is the empirical formula of the compound that contain 34.3% sodium, 17.9% carbon and 47.8% oxygen by mass? This is very similar to the previous question. First, let's determine the molar ratio. Each percentage value, let's divide by their atomic masses. So sodium atomic mass 23.0, carbon atomic mass is 12.0 and oxygen is 16.0. So after we divide the percentage value by their atomic masses, the moles 1.49 moles sodium, 1.49 moles carbon and 2.99 moles oxygen. To get the whole number ratio, let's divide these number of moles by the smallest number. So among these three, the smallest number is 1.49. So each number is divided by 1.49. Then we can get the whole number ratio 1 sodium, 1 carbon and 2 oxygens. So our empirical formula is then NaCO2. 1 sodium atom, 1 carbon atom combined with 2 oxygen atom. Our third question is a compound has an empirical formula SF4, 1 sulfur and 4 fluorine atoms. So at 20 degrees Celsius, 0.1 gram of the gaseous compound occupies a volume of 22.1 milliliters and exert a pressure of 1.02 atm. So what is the molecular formula of this gas? First, let's assume this gaseous compound ideally behave. Then we can apply PV is equal nRT ideal gas equation. P is pressure, V is the volume, N is number of moles, R is universal gas constant, T is absolute temperature, temperature in Kelvin. So let's apply the values. Pressure is 1.02 atm times the volume given in milliliters. So if you divide this milliliter volume by 1000, you can convert milliliters into liters. Is equal n number of moles times the universal gas constant. The value is 0.0821 liter times atm divided by moles times Kelvin times our temperature is 20 degrees Celsius. So if you add 273 to any Celsius number, it converts into Kelvin. This is 293 Kelvin. So one unknown, that is number of moles of N. So after you solve this, you can find out N is equal 9.37 times 10 to the negative 4 number of moles. So if you know number of moles and the mass of the compound, you can calculate molar mass. So number of moles is equal mass divided by molar mass. Number of moles we calculate and the mass is given in the question, and then molar mass should be 106.7 grams per mole. Now our empirical formula is given in the question SF4. So if you find out the mass of SF4, one sulfur is 32 plus one fluorine is 18.99 times 4. So our empirical formula weight is 107.96. So the theory behind here is empirical formula is the smallest whole number ratio of the compound. So if you multiply that mass of the empirical formula times X is equal our molecular formula mass. So after you solve, you can see X is equal 0.99, that is roughly equal to 1. Then our empirical formula and the molecular formula both should be SF4, one sulfur atom and 4 fluorine atoms in the compound. Our last question is the combustion of 0.4196 grams of a hydrocarbon. Hydrocarbon meaning is hydro plus carbon, hydrogen and carbon containing compound that release 17.55 kilojoules of heat. The masses of the products are carbon dioxide 1.419 grams and H2O water is 0.290 grams. Part 1 is what is the empirical formula of the compound. Part B is what is the molecular weight or the molecular formula of the compound if the molecular mass is 76 grams per mole. Let's go and find out how we can solve this. First, let's calculate carbon dioxide number of moles. Carbon dioxide mass divided by carbon dioxide molar mass, 44 grams per mole. Then you can get 0.0323 moles. Now you can see if you take 1 mole of carbon dioxide, there is one carbon atom, 1 mole of carbon inside 1 mole of carbon dioxide. Therefore, if we take 0.0323 moles of carbon dioxide, same number of carbon moles present, then carbon moles is equal 0.0323. Let's do the same treatment for H2O. So mass of the H2O is divided by the molar mass of H2O. Then the moles are 0.0161 moles. Again, in 1 mole of H2O containing 2 moles of hydrogen, one containing 2 moles of hydrogen, then 0.0161 of hydrogen contains 2 times 0.0161 moles. The total is 0.0322 moles of hydrogen present in the 0.0161 moles of H2O. Now we know number of carbon moles and number of hydrogen moles. This is a hydrocarbon. It contains only carbon and the hydrogen. So you can clearly see carbon moles and the hydrogen moles are same. They are equal. Then the empirical formula is CH, 1 carbon to 1 hydrogen. The ratio is 1 to 1. Now let's go to part B. What is the molecular formula of the compound if the molar mass is 76 grams per mole? If you get the empirical formula weight, 12 grams plus 1 gram for the hydrogen. So total is 13 grams. So empirical formula times N is equal molecular formula weight, that is 76 grams per mole. So after you solve this, you can find the n value, it is closer to 6. Then our molecular formula should be C6H6. I hope now you will understand how we can do the empirical formula and molecular formula problem solving. If you find this helpful, please subscribe to the channel and comment any specific area if you would like to discuss in the future. Thank you all for watching.